Chapter 7, Number 9. A child pulls a friend in a little red wagon with constant speed. If the child pulls with a force of 16 newtons for 10 meters, and the handle of the wagon is inclined at an angle of 25 degrees above the horizontal, how much work does the child do on the wagon? So we have our picture is this with our usual ground, and I suppose the wagon should be red, since they say a little red wagon. So we'll do that. And in the wagon is one of the characters. And the other person, the wagon is being pulled by the other person. So I'll put that out here. And I guess they're tethered or harnessed. I don't really know how to draw this, so we'll say something like that. And the key thing is when we go and sort of zoom in, here's the wagon, and the person is pulling, and I'm going to say there's some tension in the rod. I'm going to call it S sub t at some angle theta, where we know that F sub t is 16 newtons. And theta is 25 degrees. And then the wagon moves over some amount. So there's future wagon, and it has moved some distance d, which we know d is going to be 10.0 meters. All right, so there's sort of two ways of thinking about this. One way is to say, in sort of version 1, we can say, well, the work done by any force is the force times the distance times the cosine of the angle between their vectors. And between these two vectors is definitely theta. So we would just have the 16 newtons times 10.0 meters times cosine of 25, which is 145.009 joules, which of course is only 150 because we only have 2 sig figs. And in the usual way, Walker writes this as 0.15 kilojoules, so as to get past the ambiguity with trailing zeros in sig figs. A different way, which is perfectly fine and an equivalent way of thinking about this, is to say that the work done is only done by the part of the force that lies along. So if we take Ft and we say, well, there's an Ftx and an Fty, but only Ftx does work, then the work done is going to be Ftx times d, because it's the only part aligned with the actual motion. But then we can say, well, the cosine of theta is Ftx over Ft, which tells us that Ftx is Ft cos theta. So we get that the work done would be Ft cos theta times d, which is algebraically the same as Ftd times cos theta. So we end up with the same 150 joules, of course.